Oxidation-reduction, commonly known as redox reactions, are chemical reactions that involve the transfer of electrons between reactants. In redox reactions, one substance undergoes oxidation, which involves the loss of electrons, while another substance undergoes reduction, which involves the gain of electrons. Here's how to balance chemical equations for redox reactions. Identify redox reactions. Recognize chemical reactions that involve changes in the oxidation states of reactants. Look for changes in the oxidation numbers of elements in the reactants and products. Elements that become more positively charged, lose electrons, are oxidized, while elements that become more negatively charged, gain electrons, are reduced. Write the unbalanced equation. Write the chemical equation for the redox reaction, including the reactants and products. Use chemical symbols and formulas to represent the substances involved in the reaction. Determine oxidation numbers. Assign oxidation numbers to each atom in the reactants and products based on their electronegativity and bonding patterns. The oxidation number represents the hypothetical charge that an atom would have if electrons were transferred completely to the more electronegative element. Identify reducing and oxidizing agents. Identify the substances that are being oxidized, the reducing agent, and reduced, the oxidizing agent, in the reaction. The reducing agent donates electrons and undergoes oxidation, while the oxidizing agent accepts electrons and undergoes reduction. Balance half reactions. Separate the redox reaction into two half reactions, one for oxidation and one for reduction. Balance each half reaction separately by adjusting the coefficients of reactants and products to ensure that the number of atoms and charges is equal on both sides of the equation. Balance charge. Balance the charge in each half reaction by adding electrons, E, to one side of the equation as needed. Add electrons to the side with the higher oxidation number in the reduction half reaction and to the side with the lower oxidation number in the oxidation half reaction. Balance mass. Balance the number of atoms of each element in each half reaction by adjusting the coefficients of reactants and products. Ensure that the number of atoms of each element is the same on both sides of the equation. Combine half reactions. Combine the balanced half reactions to form the balanced overall redox equation. Cancel out any electrons that appear on both sides of the equation. Verify. Check that the number of atoms of each element and the total charge are balanced in the final equation. Ensure that the equation obeys the law of conservation of mass and charge. By following these steps, you can balance chemical equations for redox reactions, ensuring that the number of atoms of each element and the total charge are conserved in the reaction. Balancing redox equations is important for understanding the stoichiometry of chemical reactions and predicting the products of reactions involving electron transfer.